Can Zig really compete with C? That is a question we are actually not going to answer. This is just a simple look, really, at Zig and C and how they differ. And I want to just get straight into it rather than delaying it. I will only note that this is a companion video to a deep dive, kind of high level video comparing C and Zig. So please do check that out. This is just, scriptless. I don't have a script. I did some amount of setup and research and making sure all these examples worked. But, it's pretty simple. So today we're just going to look at, hey, what is the difference? How do they compare syntactically and such? And how do they, within the limited examples we have, like how do they compare in performance and such? Like this is not going to really be mainly about performance, but you'll see a little bit of that, I would say. So first, let's look at C. So this is our hello world C example, which it's not actually hello world, it's an add, but I just called it that just because. As you can see, it's pretty simple C, right? Got our add function here. We call it here statically, of course, and print out the result. If I do this, and then hello, and let's create our hello world executable. There it is, and then I should be able to run this. Hey, look at that, 3 plus 4 equals 7. We can do math, guys. That's great. So yeah, pretty simple. So for the next thing we're gonna do, let me just delete it. And let's look at Zig. So again, remember this. Now let's look at Zig. So it is eerily similar, right? Eerily similar, including the fact that you're importing something called std, right? It has that similar concept, like, oh, to, output all your stuff, you need to import the standard library. Pretty familiar concept. And you still have a function, which, no, we didn't really have to add anything saying this was static. Must be something that's already automatically done. And then we pass in, again, same thing, we pass in our variables. If you remember, have int x and y there. In this case, it's also int x and y, except we're specifying this is like the 32-bit version of int. So there's that. And then public main. So here's us creating our main function. Just again, if we go back, just like this, and saying it's a void, right? So returns a void. So this is all pretty usual. Note that it's automatically using, we'll get into an example with comptime, but notice it's already kind of saying this is a comptime int, I guess because we are using literals. We're using literals here, 3 and 4. It's just automatically going to set those at compilation time, which can speed things up a bit. So that's great. That's something you don't really automatically get with C, now without setting up something a little different here. And then we have our result. We add that. And notice when it's grayed out here, in my IDE here, I'm just using Visual Studio Code with the Zig extension. That means it's basically inferring the types here. So whereas C, you have to specify all the types all the time, which is fine. That's pretty normal for these low-level languages. In Zig, you don't have to. It can really fill in the blanks, especially if you specify here that, hey, we're dealing with ints. It can then infer from that, like, oh yeah, this needs to be a comptime int, this needs to be an i32 int, right? Anyway, enough rambling, let's just run it. What it would look, one of the things that's kind of cool is you can build with Zig, but one of the things you can do is say Zig run hello world Zig, and it just automatically runs it right there. You don't even have to deal with like, I can refresh and prove it to you. There's not even executable there, just ran it just like that. So that's pretty cool. Yeah, so that's our hello world example. Next, I'm just going to do in the order of the things I showed and talked about loosely, roughly, error handling. This is it's a little large compared to what we're going to see in Zig, but this is essentially our file reading example. I'm not going to go into every little detail. There are some comments here, as you can tell. But essentially, kind of like the one Zig example I had in the video, is you're trying to open, and it even shows the line here, you're trying to open something called data.txt, right? You're trying to open that, and it's expecting it to exist. And the way this is kind of set up, it's already printing an error for you, right? So it just tries it, and if there's no file, then it prints out something. This is trying to read the contents again, like if something goes wrong, it does that, blah, blah, blah. You see there's a lot of manual setup here in terms of detecting errors and then spitting them out. So if we were to run this right now, so let's go. Yeah, let's just call it error handling. There we go. And then we can run our error handling executable. Hey, shocker. It failed to open the file because that file does not exist. And just to prove this doesn't fail no matter what, we can add a txt file, say bananas. And then run it again. We don't have to recompile, of course. File contents, bananas. So it does work, but it's going to throw an error if we can't find our bananas data text file, right? Now let's delete that for now. And also delete our error handling executable there. Now let's look at the Zig version. Pardon? Yeah. Notice it's a lot shorter. Partially because we're not trying to actively check for it, but also because we have this try here. So literally what it just does is that it'll try to do something, and if it runs into an issue, it'll throw the error properly. And same thing if you try to read it and something goes wrong, right? Yeah, it's just a lot shorter. You don't have to take into account as much, just tries it and then fails. So let's go do, and also notice we're using an allocator here, which we're going to talk a little bit about in an example. It's using allocator and then freeing the contents, right? So it is doing some very simple memory management here. Okay, so let's go ahead and run it. So, and I'm going to prove that this does create an executable. So let's do a build exe. So don't do just build. That's going to try to build our build zig file. We're going to run into issues otherwise if you don't do it properly. Let's do build zig build -exe. All right, and then let's point to our error handling zig file. Boom. And it automatically created an error handling executable. And there's a bunch of logging here. But at the root of it is file not found, right? So it's a little bit ugly. That's partially why the C kind of had some of that formatting, but you can at least see at the very beginning that the issue is, of course, we couldn't find the file. And again, just to prove that this indeed does work, apple. I like bananas a lot better than apple, but we'll do apple. And then run it again. Boom, it found the file contents, apple. Excellent, right? So that's error handling in Zig in a nutshell, and I'm sure you can do much crazier things, but I'm not, just FYI, I'm not a Zig expert, okay? So I'm not going to know every single possible thing you can do in Zig, but this is just a simple example of that. All right. So next, let's go. What would be a good example? I don't remember off the top of my head the exact order of the video, but how about we go into the C import one? This is actually kind of cool. I'm just kind of finish up anything that's kind of has an equivalent C file and then compare to the Zig, and then eventually we'll get to some Zig stuff that doesn't really have an equivalent. So we'll get there when we get there. Here we go. So in this one, all we're doing is we're importing the stdio.h file and the math.h file. So those are C files, C header files. And we're getting the hypotenuse, which, how long has it been since you've found the hypotenuse of everything, right? I forgot this even existed. Honestly, we just don't really find the hypotenuse of things in at least the programming I do. So we're gonna print that out. So that's pretty simple, right? It's just C, because GCC C import and C, and then we'll do C import. Boom, it's there. Let me get just rid of this crap here. We don't need it right now. Brilliant. Hey, the hypotenuse is apparently 5. I'm just gonna trust it because C calculated it. I can trust C. All right. Wait a minute. Okay, so that was the C one. But here's the crazy thing, right? This is in C, right? Importing C libraries. That's not unusual, but you can do the same thing in Zig, as I mentioned in that video. And here's an example. I don't have a code example for that, but here's a code example for doing that. Again, we're importing std. That's not unusual. The thing that's slightly more unusual is we're using C import. As it says in the documentation right there, it's a function that parses C code and imports functions, types, variables, compatible macro definitions into a new empty struct type, and then returns that type, blah, 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 right? And it's just a lot of words saying, hey, you're importing C libraries and you're actually able to use it and include it, right? You C import, C include, and now you have, C, as it says, it's in a struct here in the C struct. And then you can call that same hypotenuse function right here and then print out the result just like in that other one. So I'm just going to do zig run since that's easy peasy. Zig run C import demo zig, and oh no. So this is actually good learning lesson here. You do have to connect it to the libc file here. The libc kind of library, C libraries here. And the way to do it, and I forgot to do that, is you gotta go, I'm gonna go try to find it. So here's the proper command for this. So you do a zig build exe C import zig, do that, and then you can run it. Here we go. And again, I'm sure there's a much better way of doing it. I'm not the expert. There we go. But I can prove it works, right? That's great. So we get the hypotenuse from that. So there we go. That's how you can do, C stuff in Zig. That's pretty cool, right? All right. So next, we're going to go look at memory management. Because again, comptime doesn't have an equivalent. We're just going to try to get through the C stuff first. Let's go to C. And I'm not going to go over every single thing here. But no, this is just kind of a demo of doing, the allocate kind of memory stuff. You get your initial heap buffer, write some data safely, grow, need more space, so you reallocate some memory, etc. You append more text. Demonstrate zero initialize allocation with C allocate. Yep. So just a bunch of memory stuff, and you can run that just fine. There we go. And then we can run the memory demo, which is really just kind of showing you adding that stuff. So, right, so buffer says hello from C, so you can see the memory there, and then see us adding it eventually, and then printing that out, hello from C, extra bytes after safe reallocate. Yep. And then also we're getting the sum after, I think sum after a cleanup or something somewhere. Yeah, using the array. Yeah, and then you free it up. Yep. So that's all that is. Now there is allocators. So it's the way Zig handles it, Again, I'm not a Zig expert, so I can't go too deep into how each and every one of these works, but essentially you have different allocators for handling. It's manual memory management, but you're using specialized allocators for this. So here's your page allocator. As it says, it's an OS kind of backed memory buffer. So you have that. You put some data in, right? You try page allocate, and then you can free it up, right? You can fill up buffers and print the buffer out, right? You have a fixed buffer as well. So I suppose you can't really expand that. Then you got our arena allocator, bulk free, right? And you can see these are all, if we do a zig run on this, we can definitely do a zig run on that. You can see all those work perfectly fine. This one's just a bunch of uppercase A's because that's the element we filled it up with. So yeah, so that's allocators, right? It works roughly the same. You allocate memory, you free up memory, etc. So that's that. So those are really all the C related stuff. Next, we're going to look at things that are very unique to Zig. And we're going to look at comptime. Comptime is a perfect example of something that's rather unique to Zig. So this is something, again, I say that, but I'm sure you could do something very similar in C, but this is something pretty much built in to Zig, which is kind of nice. So right here, you can say, hey, for this function, this is going to be a value that's added during compilation time, right? It's not a runtime value. Same thing with generics. This is a language that has generics. I'm also showing off generics here. This is a language that has generics, and you can see what this does. And as it says in the comment there, 2 and 3 become, well, at least just getting 2 at least. 2 becomes a constant, right? It's something that is available at compile time. It's not something that's added in runtime. And similarly with the generics, even though it's a generic, it's something that will get processed at compile time. And you can see this running perfectly fine. Right there, yeah. So 5 equals 5. And we're not dealing with something too intense as far as performance goes. So this doesn't show like any of the gains you might get when you can set something at compile time, but it's nice to know that we have this. Next is the build.zig. I talked about it. I didn't really show an example, but here's an example of the build.zig file and how this would work and how you could add different executables to your build and how you could run it and add different other executables as part of a package. So, and you can link any needed libraries, etc., etc. You can see how it's not pretty. It's not pretty. It's not very standardized. It's pretty you might say unopinionated. You can do a lot, add a lot of different sources as long as they're compatible. So it has that flexibility, but it's not it's not yet a mature standardized thing with a central repository you can reach out to. So it's something you kind of do have to work on standardizing yourself and making sure you're principled and disciplined and not do too many crazy things here. But it does work. So if I were to do a zig build, if I just do zig build, it's successful. And when we did that zig build, note we now have this zig out folder. So let's go here to the bin, and now we have our 2 executables here. So then cool thing about that is we can go, it'll let me. There you go. Bin, and then we can do zig demo. We called our hello world, right? It's referencing the hello world.zig as zig demo. We can execute our zig demo. It executes fine. And then we can do that again, but with the C import demo we did. And there you go. That worked fine because we did explicitly say, hey, link our C libraries to this. So that's great. So yeah, that's really Zig in a nutshell. I don't think I did every single thing. This is the stuff I had time for because, again, I do what I can with the limited time that I have. So I really appreciate your support for me in the other videos. And if you have any comments, praising me is great, but more importantly, really for my growth, criticizing me, please do give me some criticisms. I hope you like this video, comment on this, and let me know anything I missed or I got wrong, or I know one comment in the last video is like, do you even know what you're talking about? And I said barely, because I barely know sometimes what I'm doing here, but I at least try. I learn. Hopefully this was a lot better than the C and assembly video. I at least should hopefully sound like I kind of know what I'm talking about here, because I did do some sort of setup and research before. So yeah, so give me your comments below what you think about these videos, about C, Zig, whatever, and don't forget to like and subscribe. I'll see you in the next one. If you like this video, watch this video here for more tech talk.